Welcome to this introductory Lasal class 2 video. In this video, we will build a simple incremental counter. Right, so to start off with our incremental counter, we will simply create a new project. Now this can be achieved by either clicking on New Project or clicking on File, New Project. The project is by default saved on C. I will, however, for the purposes of demonstration, put it on the computer's desktop. The project name I will call Counter Project. Right, now that we have a new project, we should see some output generated. If we follow through with this output, we will see that this is simply the Lasal IDE creating a new project, the compiler compiling that project, linker linking it, and completing with no errors and no warnings as we would expect for a brand new empty project. You also now see that all the items here are clickable. In the right hand side, in the tree view, you find the project name, which shows you that a project is loaded. Another way to know that a project is loaded is to look at the project name in the top toolbar. Right, so to start with our counter now, we need to first define a class. Now in the object-oriented paradigm, we have classes and instances. These have various names, but the general naming convention in Lasal Class 2 is classes and objects. A class is simply a definition of some code, of a structure, and a object is an instance of that class. A class in and of itself only defines how memory should look, but does not actually take up any memory. It does not actually perform any tasks in and of itself and must first be assigned to memory, thus an instance of it created. We will do this now. So to create our class, we'll go to our class tree view. We'll right click on our project name and select Create Class. This creates a new class in our project tree view. In our case, we will call this our counter class, or just counter. Now we have an empty class without any code or any methods attached to it. Double-clicking on this class opens up the code editor, and you see that there is no code in there and no methods defined. Now you can define methods and call them from other classes, or you can define methods and call them internally, but you first need something to happen cyclically for work to occur. So what we can do is define a method which is called at a certain interval by the multitasking system in Lasal OS. To do this, you simply select your class, look at the right hand bottom properties pane, and you find a task settings option. Once you expand task settings, you see that there are flags for real-time task, cyclic task, and background task. Each of these are relative to a multitasking priority level. So to add a method that is of real-time multitasking priority, we simply set the real-time task flag to true. Now we see that a method has been created inside our class. This basically means that whatever time we set here in the properties pane, at that interval, this method will be called and executed. So looking down towards below our real-time task flag, we see a option called default real-time. Now default real-time is basically the interval at which this method RTWork is executed. So let's make this say 100 milliseconds. So I can simply type 100 and it will assume milliseconds, or I can type 100 milliseconds, which will be translated to milliseconds, or 100 seconds would be seconds, and so forth. Right, in our case, let's just leave it at 100 milliseconds. So now we know that this code, whatever I write in here, will be executed every 100 milliseconds. Right, so now let's have a look at the definition of our class. When we expand our class, we see that we have currently servers and methods. You can add many different things to this class, like variables and clients and structures and type definitions and so forth, but in our case we will simply use one server. Now a server can be thought of like a sort of a variable. A server can contain data and can be read by other classes. If you make the server non-write protected, it can also be written to by other classes. This is part of the client-server model, which we'll look at in detail at a later stage. In this case, all we need to note is that we already have one server, and that this server has the ability to contain data, to be used as a variable, and is also visible to classes in the in next to our class. Right, so now to use our class server, we simply have to type the name of it. So I will create some space, and when I start typing class server, autocomplete suggests class server, and I can just press enter. Now class service is written, and I can assign some value to it. As you can see from the bottom line in the structured text paradigm, the becomes operator, which is a colon equals, is the assigning operator. So we can say class server becomes class server plus 1. And then we end off our coding line with a semicolon. So what will happen is every 100 milliseconds we'll pass here, and we will read class server, add 1 to it, and write it back into class server. That's just incrementing class server by 1. Right, so now we have some functionality written inside our counter class.